What if the universe is dominated by something we can't see, can't touch, and can't escape, yet it controls the fate of galaxies, stars, and even our planet? Dark matter makes up most of the universe's mass, but we still don't know what it is. And here's the big question people keep asking. Is it dangerous? In this video, we'll dive into what dark matter actually does, whether it can harm Earth or humans, and why understanding it may be the key to solving the deepest mysteries of the cosmos. If this invisible force rules the universe, it's time we finally understand how. Dark matter is often described as the universe's hidden skeleton, a massive structure that holds galaxies together. Without it, the Milky Way wouldn't exist in its current form. In fact, when scientists studied how fast stars orbit the galactic center, the numbers made no sense. Stars far from the center were moving just as fast as stars near it. That should be impossible unless a huge amount of unseen mass is pulling everything inward. That extra pull is dark matter. What makes this so strange is that dark matter doesn't interact with light at all. Telescopes can't see it, no matter how powerful they are. Instead, scientists detect it by observing gravitational lensing, where the gravity from massive clusters bends the light of distant galaxies like a cosmic magnifying glass. These distortions reveal that up to 85% of the mass in these clusters is invisible. This invisible mass stretches across enormous cosmic scales. Dark matter forms vast halos around galaxies, shaping the cosmic web, the huge structure of filaments and voids stretching across billions of light years. Without dark matter's quiet gravitational influence, the universe as we know it simply wouldn't have formed. Yet for all its power, its effects on human scales seem surprisingly gentle. When people hear invisible mass surrounding us, the first fear is usually, can it hurt us? Surprisingly, all evidence says no. Dark matter doesn't collide with atoms, doesn't create radiation, and doesn't interact with our bodies in any measurable way. In fact, billions of dark matter particles may pass through you every second without leaving a trace. That's how weakly it interacts. Its gravitational pull near Earth is also extremely small. The amount of dark matter in our neighborhood is so thinly spread that its total effect is less than the gravity of a pencil lying next to you. Even the moon's tidal pull on Earth is trillions of times stronger than anything dark matter does locally. And dark matter doesn't clump into dangerous objects the way normal matter does. It doesn't form stars, planets, or black holes. Instead, it remains widely diffused, forming large halos rather than dense balls. This means there's no risk of sudden dark matter collapses, explosions, or invisible collisions. Even high-energy physics experiments like the Large Hadron Collider haven't shown any unsafe interactions. Nature produces far more energetic collisions through cosmic rays every second, and Earth hasn't been destroyed by them. In short, dark matter shapes galaxies, not disasters. If dark matter isn't dangerous, why does it matter so much? Because understanding it may reveal the next big breakthrough in physics. Every major step in science, from discovering atoms to unlocking quantum mechanics, started with invisible mysteries that didn't fit our understanding. Dark matter is the next frontier. One possibility is that dark matter is made of entirely new particles, unlike anything in the standard model. Discovering them could rewrite the laws of physics. Another possibility is that dark matter interacts with gravity in a way we don't fully understand yet, hinting at undiscovered forces or dimensions. Experiments worldwide, from underground xenon detectors to space-based telescopes, are searching for the first direct hint of its true nature. Dark matter also explains the formation of cosmic structure. Its gravitational pull acted as the scaffolding that let gas gather into the first stars and galaxies. Without it, the early universe would have been too chaotic for complex structures to form. Even today, dark matter continues to shape large-scale motion across galaxy clusters, influencing how the universe evolves over billions of years. So while it poses no threat to humanity, it remains a crucial piece of the cosmic puzzle, a missing ingredient that could transform our understanding of reality. Dark matter may be invisible, but its impact is enormous. It holds galaxies together, shapes the cosmic web, and influences the evolution of the entire universe, all while passing harmlessly through us every moment. Understanding it could unlock new physics, reveal hidden particles, or even reshape our ideas of space, time, and gravity. The mystery is still unsolved, but the search is one of the most exciting scientific quests of our era. If you enjoyed exploring this cosmic enigma, make sure to like, subscribe, and share. There's much more to uncover, and the universe is full of secrets waiting to be explained.